Good afternoon, ladies and gentlemen. Thank you for joining us today. Another webinar presentation proudly brought to you by the ARB Group in association with Austroads. Today we'll be covering accessibility-based network operation planning, and we'll be having Ian Espada of ARB Group in the studio to tell us a little bit more about that. But before we begin, I will move through a few housekeeping items quickly for those of you who have not attended one of our webinars before. My name is Angela Juhas and I'll be your webinar moderator this afternoon, so if you experience any issues along the way, please feel free to contact me and let me know and I can help resolve those for you. Now today's session, I think we've got about 60 minutes in total, so we anticipate leaving about 15 minutes of our time with Ian this afternoon to answer any questions you may have. And we are recording today's session, ladies and gentlemen, so there's no need to take notes frantically. All of the presentation material as well as the recorded material will be sent to you once the webinar has concluded. Now, webinars are more enjoyable when they're interactive, so if you have questions for Ian or myself, or have something to say, or any other comments or feedback, please do type those into the questions box, which you will see within your control panel. We don't have a slide for it, but ladies and gentlemen, I will also draw your attention to the chat function within your control panel. Periodically I might type in a discussion topic in there, and would love to hear your feedback on that. So periodically do check your chat box also. Now, we've heard enough from my good self, and so I'd like to hand over to our presenter today, who, as I mentioned, is Dr. Ian Espada of ARB Group. Now, Dr. Espada holds degrees in Traffic Engineering and Transport Planning from the University of Tokyo and Asian Institute of Technology, as well as in Civil Engineering from the Central Philippine University. From 2001 to 2008, he worked as a transport planner for Almec Corporation. Dr. Espada joined the network operations team at ARB Group in 2008, where he is currently the team leader. So welcome to the studio, Dr. Ian Espada. Lovely to have you with me. How are you today?
Thanks, Angela. Very good.
That's the way. And would you mind telling us a little bit more about what we're covering in today's presentation?
Thanks. Today we're going to cover the Austroads project on accessibility-based network operations planning. One of the drivers of this project is we wanted to look at the network operations planning framework, which has been successfully implemented in Australia, especially in Victoria, where the network operations planning was able to guide the development of strategies and treatments to address network efficiency issues and network safety issues. Then the natural evolution of this concept then would be to look at how this concept or how this framework can be used to deal with higher level outcomes, which is accessibility, which is, if you come to think of it, would be the end game, where we mobility, congestion, and safety are all really to support movement of people from their points of origin to various valued destinations. So we're going to look at how we'll be able to use this framework, which was used in GTM4, Guide to Traffic Management Part 4, and develop that further and apply it to achieve, potentially achieve accessibility outcomes. The second objective, driver of this project, is to extend the previous work in 2011, Austroads NS1586. That's the development and application of accessibility metrics. We have developed, we have analyzed various metrics in that 2011 study for work, education, retail and recreation, and we would like then to cover broader types of accessibility, including health and community, and one that is particularly difficult is freight accessibility. And we would also like to have demonstration projects, and we did one for this project, which is the Burwood Heights Activity Center case study. And we did two levels of analysis. One is a much more fine-grained neighborhood level analysis to demonstrate public transport, walking and cycling accessibility to various destinations. And we also did a much more regional level or metropolitan level, focusing on car and freight accessibility. And finally, we'll come up with some this is leading into. But before I start with the presentation, I'd like to acknowledge Austroads. Austroads is the funded this project, and through monetary means, and also through access of the various road agency experts who contributed significantly to the development of this project. And also the various stakeholders, Australian Bicycle Council, the various local ALGA, and the various freight stakeholders and health sectors who contributed in the development of, or better understanding of the health and community and freight accessibility used in this project. All right, so firstly, why do we care about this issue? The 2010 social survey conducted by ABS provided some insight on how big the accessibility issues are with regards to transport-related issues. So their survey, which is nationwide, identified about 12% of the population have accessibility issues, and the particularly vulnerable are the young adults and the aged and the females. The issue that they have raised is really dependent on car ownership and access. So that's what they're finding. That good accessibility seems to be requires good or high car ownership and access. Now, in a country like Australia, car ownership is definitely high. However, it's sad we cannot have 100% car ownership and car access for various reasons, such as lack of driving license, lack of driving skills, or simply that the households don't have enough cars. ABS data analyzed by Charting Transport, for example, the bottom there, the bottom figure, shows different types of household structures and how much car access is available. Limited motor vehicle access means that there's more adults than cars. So that means one or more adults will not be able to access a car if somebody else is using it, and no motor vehicles, there's none at all. So we can clearly see that even such a high saturation of car ownership and car access in a country such as Australia, definitely there are people who will be left behind. So let's look a little bit more deeper into what's going on. What is in front of you is an analysis done in 2011 for Perth, and there's a similar one in Melbourne, both showing the same thing. One dot there represents about 200 households in a traffic zone, and the scores goes from 0 to 1. 1 meaning you have perfect accessibility to work, and 0 means you virtually very limited accessibility, and the gradient goes from poor to good. Now, for car accessibility, you can see it's very good all throughout, largely all throughout, except towards in the suburban areas, outer suburban areas, and some of the rural areas, where the accessibility goes really low, and we would expect that there will be some accessibility issues by car.
Sorry, Ian, we've just had a couple of people saying that the slides haven't transitioned. So what I'm going to do is, if you could try flick over to the next slide, see if that makes a difference. Otherwise, I will change it from my end. And if people could let me know if you can see that accessibility issue slide that Ian was referring to just one moment ago. And this is the accessibility to work map.
Right.
Yes.
Okay.
You can see that okay at your end? Ian?
Yes.
Yes? Okay, fantastic. Okay, so can our audience. I might just control the presentation from here. Will that be okay?
All right, sure. Moving to the, sorry. I'd like, on the left-hand side, that's car accessibility, showing some of these largely good accessibility if you have a car. Now, what happens if you don't have a car? On the right-hand side is public transport accessibility, using the same accessibility score index. Now, a little bit careful about the bins being used. The light blue, 0.45 to 0.65, is not the same as the light blue on the left-hand side. It's roughly equivalent to the green. So you can already see that the public transport accessibility, once you don't have a car, you're limited to public transport as your only option, then the level of accessibility drops significantly. Now, next slide. Accessibility to work, showing cycle and walk. Now, looking at cycling and walking, it gets even worse. Again, be careful of the bins here. They are not equivalent to the car accessibility. The 0.2 to 0.4 is light blue, is already red in the case of car accessibility. So one can see that if you don't even have public transport options, the cycling and walking accessibility issues is even much significantly worse. So one can imagine the need for car in a city such as Perth, and more generally, I suppose, in Australia. Now, moving on, accessibility mode share. One of the things, of course, if you have poor accessibility, your ability to participate economically and socially, and be able to derive various social services such as healthcare and whatever, is already constrained. But there are also some sustainable transport issues associated with this. Now, what you see on the left-hand side is the mode share by various trip purposes in Melbourne. And overall, roughly about 80% is by car. And work-related is roughly the same. And it varies from different trip purposes, but really we can say it's dominated by car. And the 2011 study demonstrated that to a large degree, or at least to some degree, accessibility by public transport, cycle, and walk has an impact on the mode share. So from a mode share perspective, which has significant implications, and various other benefits, health benefits of active transport walking, limitations of the accessibility by public transport, cycle, and walk is at least one of the causes, if not a major cause, of poor limited options, hence significantly high mode share for car. There are significant benefits from moving away from mode share by car, such as health-related benefits, decongestion, and the lessening of infrastructure costs to provide enough supply to meet the same demand. So there are motivations. These are motivations wherein why we are dealing with accessibility. Next slide, freight accessibility. Now, with regards to freight accessibility, some of the key constraints from that came out of our interviews from key informants is that they are much more concerned about OH&S regulations with regards to accessibility. Now, that means that for longer trips, interstate trips, where they need to comply with OH&S regulations. So, say for example, every 5 hours of driving, you need to have a certain amounts of rest. In a metropolitan situation, this doesn't really apply. So, because the OH&S regulations really come into play when travel time is more than 2 hours, which is really beyond metropolitan travel. However, in the case of even at metropolitan situation, the travel time reliability is becoming more of an issue. Logistics requirements and gateway requirements, such as port access, for example, are requiring much more stringent arrival windows now. So, for example, this already reports on 15-minute windows, so you must comply with that, or otherwise penalties apply. There are, of course, the well-known curfews and last-mile access. That was also an issue for large, heavy vehicles. And also, they noted on various other constraints to their operations, such as information on severe delays. The lack of information on severe delays does not allow them to efficiently coordinate their truck delivery schedules. Poor pavement conditions may not be a significant issue in the metropolitan case, but certainly in the rural area it is to some degree. Now, safety of driving and availability of rest facilities for drivers is certainly a big issue, quite related to the OHS regulations. Okay, so the next slide, factors affecting accessibility. So what are the things that we need to consider that we can say that a certain user has good accessibility? There are four major factors that we need to look at. The first one is the quantity of travel time, the quality of travel time, and the nature of the traveler. I'll go one by one. The first one, opportunities. Next slide. There are two kinds of opportunities available. One that is mostly heterogeneous and one is mostly homogeneous. Example of a heterogeneous opportunity is employment. Okay, so there are different types of employment jobs available: clerk, engineer, doctor, nurse, teacher, etc. And the skill level is also varied. So, and also the pay scale, the level of the hierarchical level in the organization also differs. So what that means is that when we're dealing with heterogeneous heterogeneous opportunities such as employment, the search area, the number of employment or jobs that need to be accessed within Access is bigger, because you need to have to scan a large number of jobs to be able to find the right job that will fit you. So therefore, it doesn't necessarily mean that you have good accessibility if you are close to a factory. For example, you may not be a factory worker, or your skills not suited for a factory. So therefore, just being close to a factory doesn't necessarily mean. You need to have more to be able to meet your accessibility requirements. The same with tertiary school. There are different courses, different levels of universities. So you do need also significant amount of tertiary school opportunities to be able to meet your accessibility requirement. As an estimate is something like 120,000 jobs is necessary to be able to meet your accessibility requirements, or something like 40,000 to 50,000 enrollments is necessary for you to be able to find the right tertiary school for you. On the other end of the scale are homogeneous opportunities. These are ones that are more or less the same wherever they are. So one good example is grocery store. And grocery store may differ to some degree, but not really a lot. So hence, having one grocery store is enough to meet your accessibility requirements, maybe one or two. So these are a much more easier types of accessibility to meet. But we do have to be cognizant whether the kind of accessibility that we're dealing with is heterogeneous. Then we need to identify different destination points to be able to be accessed by the traveler. But in case of a homogeneous, providing one opportunity or one or two would be adequate. Now, in the case of freight accessibility, is a little bit more special because each stakeholder has very different requirements, so we cannot generalize it easily for freight accessibility. However, there are identified key gateways and key freight ports and airports that would serve as general key destinations for freight. but it's really on a case-to-case basis, and it's not cannot be easily generalized. Now next, the quantity of travel. So quantity, this what you see in front of you is research done in 2011 for development of accessibility metrics. The y-axis is the weighting factor, which is kind of like a measure of ease of access, or ease of going to a particular destination, and the x-axis is the transport impedance. Think of it as travel time. That's a simple case. Now you can see that different types of travel, trip purpose, has different sensitivities to travel time, and work, for example, is much more we're not as sensitive compared to, say, primary and secondary education and shopping and recreation. And if you look at walk, the other important point here is that there is a level of limitation to what would be considered desirable travel time. So beyond, say, for example, 50 minutes or 60 minutes by car would be considered highly undesirable. So we have to be cognizant of both this median desirable travel time, which is probably around weighting factor of 0.5, and the maximum representation of the maximum desirable travel time, which beyond this travel time, we are really experiencing severe feeling the budgetary constraint of travel time, or time constraint over the course of the day. So you can think of it like everybody has 24 hours in its time budget over the day, and some of it will be spent sleeping, some of it spent eating, working, and if you can order them in terms of value or priority to the person, travel would be somewhere around 1 hour. You have to spend about 1 hour of travel for various reasons. When the travel time increases, you have to eat up on some of these other valuable activities, such as watching, playing with your kids, or doing exercise, which is important for health benefits. So increasing the travel time beyond a certain amount would cause would cause you to trade off some other time, some other activity, and will either cause you to not travel at all, or find a destination that is closer, or even relocate to be able to meet your desirable travel time, or travel time, maximum travel time allotted to travel. All right. Next is the quality of travel. For accessibility to be good, we need to look at various aspects of travel. So just because you're traveling at a certain amount of travel time, it may be short, but there are other considerations, in particular safety. So if the travel by walking is short enough, but it would require you to cross a dangerous crossing, then that is not accessibility. It impinges on your accessibility. Now, there are various aspects beyond safety that needs to be considered. Mobility, for example, travel time reliability is a component of mobility, hence it's there in the list. Access is what we mean by access here is physical access, so that's self-explanatory, especially for wheelchair-bound travelers. Physical access is very important. Traveler information is, for example, in the case of freight, they do need to have information about severe congestion to be able to manage their trucking schedules. And amenity. One interesting example is in case of amenity is in the UK. They look at the accessibility of elderly people to the town center, and because the distances are long, and the walking distance are long, and the endurance of aged people is limited, one of the constraints to accessibility to the town center is the lack of benches, so that walking aged people would be able to take a rest So one of the things that were identified to improve accessibility to the town center was to improve amenity, such as providing rest areas and sitting benches for elderly people. So we cannot really generalize that this is more important than the other. What aspect of travel is more important than the others? We need to look at the specific requirements of the traveler, and we may, as far as our interviews of various stakeholders are involved, each one is important, maybe to different degrees, but nonetheless important and cannot be neglected. The nature of the traveler is the last one, and this is quite self-explanatory. So we do need to look at whether there are specific limitations to the traveler that we are dealing with. So in particular, if we are developing a network operations plan in an area with, say, an aged care residential retirement village, so we do need to look at specific requirements for those kind of people. Children, accessibility around schools, for example, we do need to look at safety a little bit more closely than, say, for example, in the case of an employment center. So the level of service for safety requirements may be higher in certain cases. Okay, next slide. Network operations planning. Okay, so this brings us to network operation planning. Network operation planning is a framework of multimodal framework to design various operation strategies and treatments to meet the community requirements. Now, the way network operation planning is being implemented, and also as it is documented in the Guide to Traffic Management Part 4, is the focus is on link level analysis. So there's level of service gaps for a particular link or particular node, and treatments are applied. We would like to extend these framework to cover accessibility outcomes. And the two areas where network operation can contribute to accessibility are in two areas. The first one is quantity of travel, that is means travel time. Say, for example, by reducing the delays or providing sufficient crossing opportunities can significantly improve travel time, or even for providing more direct public transport services is also another possibility to improve quantity of travel time. The other one is the quality of travel time, or the quality of travel, and that means amenity, safety, information, and also travel time reliability and so on. So all of these are under the scope of network operation planning. There are, of course, others that are outside the scope, such as providing new schools where there are no school and so on. But these are much more broader issues and definitely outside the scope of a network operation planner. So to give you a clear idea of what network operation, what are the outcomes of a network operation planning, is these table, which shows you some strategies and treatments or options that are available. Now, network operation planning is really to get these various operation strategy and treatments to align themselves such that you'll be able to meet community requirements. Now, the crux of this framework is really how to manage the various trade-offs, because under the existing conditions in Australia and New Zealand, there's very limited road space. So we cannot do everything. We cannot meet everybody's requirements. So we need to trade off, or sometimes we need to balance and manage these various road user requirements and be able to meet them in the most efficient way possible. Now, in an accessibility-based network operations planning, the lens that we have to use is really to align these various operation strategies and various treatments to meet an accessibility outcome. Okay, so I'll take a quick pause and see if anybody has a burning question or before I move to the next
Thank you, Ian. That's been really interesting so far. Look, we've had a couple of questions. I have one here from Bruno, and Bruno's referring to the graphics earlier on in the presentation for cars, public transport, cycling and walking, and his question is, how is accessibility measured in those graphs?
Those graphs measure almost like the traditional way with some refinements. Think of it like it is a weighted, normalized, weighted sum of opportunities available. So the weight is based on the distance, so if the opportunity is furthest away, so the weight is reduced, and then it is normalized. It's normalized to the maximum level of accessibility that is possible to meet, to satiate accessibility requirements. So that means, for example, in the case of employment, you need about 150, 120,000 or 180,000 jobs. So if you exceed that, it really doesn't matter. The same analogy is that if you have 2 grocery stores, you're very happy. Then the 3rd grocery store, you're slightly happy. The 4th, 5th, 6th, you don't really care. So that satiation means that you're close to level of 1.
Great, thank you, Ian, and thank you, Bruno, for your question. Please keep them coming. Another question here from Chris. Chris is asking, the data for Perth and the graphs of impedance for various models are based on the Australian experience. How does this compare with the experience in, say, the Netherlands?
Hard to say. I cannot extend this result beyond what the model has been developed for. So the Netherlands may have different sensitivities to travel time and so on. So really couldn't generalize too much, although one could say people are the same all throughout the world, but I couldn't authoritatively say that it can be applied to anywhere else.
That's all right. Perhaps we can do a little bit more investigation, and if you would like further clarification or to discuss it further, I'm sure Dr. Espada would be more than happy to chat with you after the webinar. Thank you for that question, Chris. One more question here from Ingo. Ingo is asking, in the last slide, how does on-street parking fit into the NOP, as this competes quite strongly for road space? So I'll just...
Yes, that's the crux of, you nailed it there. What is that? That's the crux of network operations planning. So the network operations planning framework requires us to define what functionality the road is supposed to do. So whether the road is for mobility, in that case, then the on-street parking has no business on that particular road. But if we can, if the network if there are opportunities along the network for a parallel route to be able to serve the mobility function, then we may actually then design the operation of the particular road for access. So in that case, then on-street parking is supportive of the community requirements. Now, of course, there are trade-offs involved, some losers, some winners, but we do need to balance this in the NOP framework and be able to do it properly. Now, it could be also time-based. So weekends, for example, there's not a lot of mobility, therefore we can put on-street parking. So this is how the discussion, the to and fro discussion that would occur in a network operations planning.
Great. Well, thank you for your question, Ingo. I hope we've answered that for you. And if not, please do touch back with us later on in the presentation. Ian, I might let us move on with the presentation, and then we'll leave some time later to take some more questions.
Okay. All right. So let's go to the framework now. And this slide really encapsulates what it's all about. The network operations planning deals with elements of travel time and the journey level of service, using the full spectrum of the journey level of service: mobility, safety, access, information, and amenity, and aligning them so that we be able to meet accessibility outcomes. There are stages that have been documented in the report of this project on accessibility-based network operations planning. This is very similar to the Guide to Traffic Management part for network operations planning. The only difference really is instead of just focusing on efficiency outcomes, we are really looking at accessibility outcomes. And it probably, it's quite, to summarize this stages is really a top-down approach where you define various objectives and going down to specific treatments. So it's nothing new. So when we look at accessibility in a network operations planning application, we're really looking at two dimensions, the travel time and the journey level of service. Now, if you have good accessibility, then you have low travel time and good journey level of service. Failure in any one of these would make us fail in our not meet our target for accessibility. Now, when we look at travel time, we have come up with a guideline on or guidance in what would be a desirable travel time. So these are also based on the 2011 study and with further refinements through discussion with the various road agencies. And you can see here the median desirable travel time, which would be what we probably aim for. But we do have a play, and we have identified a maximum desirable travel time. So beyond this, that constraint, the time budget constraint, starts to act up a little bit more stronger. So we do need to keep within at least the maximum desirable travel time. The level of service that we need to consider is the full spectrum. And recently there was an Austroads research report that was published, Austroads Level of Service Framework for Network Operations Planning. That is a detailed description of what the various level of service is. So for example, mobility, it looks at congestion, travel speed, and travel time reliability. For safety, for cyclists, for example, it looks at safety at the mid-block, safety at the intersection, and so on. So there are various methods that will be able to assess a level of service of a particular link. But one thing is important, whatever framework you're using, we do need to understand that based on our key informant interviews, we cannot ignore any one of these. All of them are important to some degree, so we do need to look at a full spectrum if possible. Now, the journey level of service is, we need to identify where the gaps are. So because the level of service along the route varies from good to bad, and when we do network operations planning using journey level of service, we plot the level of service along the route, and we have a journey level of service target, and any level of service along that particular route that exceeded the target, and that's considered LOS gap, and that gap need to be as defined as possible. It should not be just say it needs to be very specific. The importance of that is so that later on, when we design the treatments, we know what we're talking about. You know, we have a full we have characterized fully, or to as close as possible, the problems. Hence, we will be able to guide the determination of the solutions later on. So we've outlined work accessibility, what are the key destinations, and the travel time sensitivity, and the key level of service measures as part of the documentation of guidance. We have gone through most of this already, so I'm just gonna quickly flick through them and go to the case study. So this is the work accessibility guidance on designing determining work accessibility by various modes, and this is primary and secondary school. Notice that you can see there's some guidance on what is the minimum requirements. At the minimum, at least one public school accessibility should be provided. This is, of course, quite specific to an Australian context, but of course there are other schools that are available. And you have tertiary school accessibility. Now, one thing I'd like to note that cycle accessibility here, cycle accessibility really looks at not the recreational cyclist. Of course, the recreational cyclist, the more they cycle, the happier they are. So they have quite an inverse impedance. So the longer they can cycle, the more benefit they derive. But we're talking here specifically of cycling for the sake of going from point A to point B, wherein the cyclist would like to minimize the time involved. So in this particular, which is probably the general case, in this particular case, there are limitations to what the endurance and or a normal average cyclist can do. Same with walking. Retail and recreation, and health and community, and finally freight. Now for freight, we look at what are some of the key issues, and I think we already touched on that. The key issues are really in OHS requirements, and the other one is travel time reliability issues, which probably will be illustrated much more clearly later on in the case study. So I think because we're probably running out of time, we'll move a little bit more faster, and I'll now show you the case study. The case study looks at both at the neighborhood level, focusing on public transport, walking and cycling, and the metropolitan level, focusing on car accessibility and freight. This is an application of the framework that I have just showed you. The study area is about 17 kilometers from Melbourne, and it's located here, quite close to where I am. And we're looking at Burwood Heights Activity Center. This is a greenfield development. It's a former factory, empty land right now, and it's going to be developed. And we look at the two parts, the stage one, which is the one close to Ely Road, and the other one next to Burwood Highway. Now the thing about the Burwood Heights Activity Center, there are of course accessibility targets, and I'm not at the neighborhood level, and the accessibility targets is to meet what they call as a 20-minute neighborhood, according to the Plan Melbourne document, and that means that the residents should be able to access by walking, cycling, and public transport within 20 minutes of their residence. So we adopted that sort of philosophy, and we also, of course, adopted the philosophy of promoting non-car modes. So the first thing we did was to plot out all these key destinations, the different kinds of destinations. Some are employment destinations, some are school destinations, etc. And we then selected a number of these, a representative of the key destinations. So for example, there are many primary schools, but we only selected one, consistent with what we thought that this is a homogeneous opportunity, so providing only one would be enough requirement from the point of view of the road agency, for example, to provide only one. We are happy to provide more, but we are at least obligated to provide at least one. The desirable travel time and the journey level of service have been set by us as an example, and it's quite consistent with the median desirable travel time set earlier. And the journey level of service is largely level of service C, except for primary school, where we ramped up the requirement to level of service B for safety. And using the smaller set of destinations, we then plotted the accessibility critical network. This is the network that would be used to access from Burwood Heights Activity Center to the various destinations. Hence, this will then be the focus of our analysis. I also highlighted the primary school route, which would be which would require a more stringent level of service for safety in this particular case. Now, the first thing we did was then after that is we look at the travel time from the two key origins points, so from Ely Road and from Burwood Highway, by transit and walking and cycling. Now you can see that by walking, many are unviable. Unviable means it's more than double the median desirable travel time, which we thought would be the beyond the maximum desirable travel time. Hence, travel by walking is not expected. And there are two other destinations for transit wherein the travel time exceeds what we defined as the viable, which is double the median desirable travel time. That was for secondary school, and the other one's for primary school. It's not significantly longer than the double the median travel time, but it's, according to our criteria, it is exceeded it, so we simply label it as unviable. And certainly there needs to be some improvement to be able to do that. For cycling, there seems to be no problem with regards to travel time. So that's the travel time axis. Now we look at the level of service and some of the accessibility gaps that came up. Now, with regards to walking, there's not much to discuss because of the long travel time or the long travel distance, the long distances involved. Many of these destinations are simply not viable for walking. Of course, there are some people who have better endurance, of less sensitive, who are able to walk those distances, but on the whole, it's not going to be really much. So, but there are potential viable services available by walk, childcare, retail and recreation, general practitioner, and community. But on many of the destinations are just simply too far away for walking. There are some level of service gaps that have been identified along these routes, which is long crossing delays at a particular intersection. But on the whole, it's really moot because of the long distances involved. We cannot say much anymore. So what then is the solution? Then the solution really would be to have to look at public transport and cycle accessibility, which then becomes heightened, because if we cannot do any walking, we need to at least provide one or the other modes of travel for accessibility. Now, looking at public transport accessibility, we then identify the level of service gaps along the route. I'll just highlight one. Safety in accessing the bus stops on this particular road. This is Middleborough Road. So there's no crossing, and the travelers have to cross this road without any protection. So therefore, if you want to travel by bus, you need to navigate that particular part of the journey, and that can be considered as a constraint to accessibility. And there are others, such as poor path conditions, low frequency of the bus service, lack of or poor bus shelters, and crossing delays, and others. So wheelchair access, for example, on all transit services is poor. So that's a significant constraint to accessibility to wheelchair-bound travelers. For cycling, the key issues along the accessibility critical network is mid-block crash risk, particularly on this road here, Burwood Highway, which is an 80 km/h road, and with significant heavy vehicles and car traffic. So that's a constraint in itself. So even though you have good travel time by cycling, there's very limited chance for anybody doing cycling because of the safety risk. So we have identified these journey level of service gaps in this particular slide. So what then are the operation strategies? Because of for walk long distances to key destinations, we need to compensate by improving transit and cycle accessibility. Crossing delays, we need to modify it, but really the key thing here is to enhance the transit and cycle accessibility. Walking is really difficult in this particular case. Now for public transport, now there's a long list of things that can be done, and I'll just highlight one. The long travel time from Burwood Heights Activity Center to Forest Hill College is beyond what we considered as the viable travel time. So we need to reduce the access and egress time going to the stations, or we either have to consider a more direct public transport service. And the rest follows here is all these all of these recommendations would address would directly impact an accessibility outcome. For cycling, it's quite obvious. The cycle separation and treatments at intersections is necessary at the key roads where accessibility is most important, which serves a significant accessibility role, I should say. And these are specific recommendations that comes out of the framework. So what is highlight just what this is for then is that really we are now looking at it at a very finer level. By looking at things from an accessibility lens, we're able to identify specific treatments more more precisely, and would be able to identify and be able to design the investment portfolio or the intervention portfolio a little bit more sharper, and come to the outcome that we would desire a little bit more efficiently. Now, running out of time, but so I'll have to go through a little bit more quicker. At the metropolitan level, we look at the BHAC again, Burwood Heights. This time we look at car accessibility to employment, and for freight, for all the freight gateways. The process is the same. We do have some limitations to the median travel time of 30 minutes. That means a maximum desirable travel time of 60 minutes. And for freight, the travel time is not an issue because it's well within OH&S requirements, really. But we do have some requirements on level of service for travel time reliability, which is important for freight. Now, this then is the accessibility critical routes. And we look at the travel time. There's really no problem at all for travel time. But I just like to point out congestion and speed. Just because travel time is good, that doesn't mean there's no congestion. But so in the accessibility critical network, there are heavily congested sites. But really, one would say just because there's congestion, that doesn't necessarily mean it's an accessibility issue, because as long as the travel time does not exceed the certain level, certain limit, there's really no problem. So these are, in a way, from the point of view of the Burwood Heights activities, acceptable congestion. As, of course, in the future, when the congestion becomes even more severe, then it will come to a point it will exceed the travel time targets, and therefore that becomes an accessibility issue. It is an operational problem, but from an accessibility point of view, it's not a problem at all. But the travel time is a different issue. This is a recording of the travel time from Burwood Heights to the CBD, Melbourne CBD, and you can see the median, the mean, and the maximum travel time is a percentage. So it really exceeds the set target, and we can look at in more detail where that happens, and that happens on the Monash Freeway, on this particular from Turak Road. And if you look at travel time reliability for freight going to Swanson Dock, the same thing. So this time the travel time reliability is along this particular route here. So one can see that travel time reliability is a big issue. So some of the operational strategies with regards to travel time, it's not an issue yet, at least, so nothing has been recommended. But with regards to travel time reliability, further studies is required for M1 and CityLink to find out how to improve travel time, maybe looking at non-recurrent congestion and severe unexpected delays in this particular scene. So as conclusion, we have in this presentation identified a number of transport-related accessibility problems. At the strategic level, you can see that public transport, the accessibility of Australians and New Zealanders are really car dependent, based on car access. Without car, in the metropolitan case especially, poor public transport, walking and cycling accessibility are severe constraints at the strategic level. Now, looking at more at a finer grain, looking at, for example, the Burwood Heights Activity Center, one can see that there are a lot of nuances involved in accessibility. We have to look at the specific journey, and weak links along the journey can really impinge on accessibility. So we do need to look at that. The other point is that the travel time reliability is becoming, it seems to be becoming more of an issue right now. And in particular for freight, we do need to look at ways to improve travel time reliability in a network operations planning sense. So what this means is that the extension of network operations planning to be able to address accessibility outcomes really we need to extend the way we do network operations planning. And the key point, I think, is that we need to look at travel time and journey level of service using the full spectrum. We haven't really been looking at travel time in the traditional network operations planning. We're looking at things like congestion and cyclist separation and so on. But I think we need to extend it a little bit more and understand travel time, because at the end of the day, travel time is the one that would impact on accessibility. I apologize for running a little bit over time, but it's a big project, and hope you enjoyed it.
Absolutely. There's lots to tell, isn't there, Ian? So I do apologise for going over time a little bit. If anyone does have to rush off, please do. We are recording this session, so you can always listen back to the question-answer component that we're about to do now for a few more minutes, perhaps. We have had a couple of questions, and Ian, I'll shoot those through to you now. Question from Alistair. Alistair's asking, to what extent should accessibility-based NOP take into account the environmental and social impacts of operational changes? Is this the equivalent to the third dimension of operations planning?
Certainly, and it's not exclusive, I think, because as you can tell, accessibility-based network operations planning do need to address those 12% disadvantaged citizens who cannot access them. And then the way to do that is really the enhancement of the active modes of transport and also public transport, which plays into the sustainable transport arena. And definitely they're not non-exclusive, but definitely they're quite different as well in some degree. So while there is some overlap, the environmental approach to network operations planning hasn't really been touched on yet quite strongly, but there are, as I mentioned earlier, some overlap.
Thank you, Alistair, for that question. Another question here from Brett. Brett's asking, are there any further details on the surveys undertaken to determine transport users' medium desirable travel time?
Yes, the report is available online, Austroads NS1586 accessibility-based, application of accessibility metrics. If you can Google that, you should be able to download the report.
Thank you, Brett. Question here from Chris. Chris is asking, has the Burwood Heights Activity Centre study been discussed with the local council, which happens to be Whitehorse Council? Have they shown any interest? We have informed Whitehorse City Council of this study, but we haven't really communicated with them regarding the results so far. And this is, I'd just like to stress, this is not a sanctioned study by the Whitehorse City Council, in the sense that these represents the views of the Whitehorse City Council, not at all. This is purely the views of ARRB, which can be taken as just a demonstration of the framework. Thank you, Ian, for clarifying that, and thank you, Chris, for that question. I hope we've clarified that for you. Question here from Dave. Dave is asking, how much time and effort required to produce an analysis like that for Burwood? Are any particular resources required?
The level of information, the data is the most important one. The level of data required is not significantly different than traditional network operations planning. The only difference is we do need to look at journeys, and we do need to identify origins and valued destinations. So in that particular case, it does add a little bit to the network operations planning, but not a lot. it would, since we're analyzing one particular origin, it's relatively easy to generate journeys. However, when we want to generalize it a little bit more, we do need to analyze much more origins. Hence, a software that will be able to do that kind of analysis would be helpful. But I don't foresee that as a difficult software to develop. But nonetheless, it does add a little bit more to the job, but not significant, I would say.
Great. All right, we might take one last question, and this one's from Alistair again. If anyone does have any questions that come to mind once the session is over, please don't hesitate to contact Ian. His contact details are right there on the screen, and he'd be more than happy to chat to you more about your questions and concerns on the matter. So the question from Alistair reads, what is the smallest community/population to which the accessibility NOP approach is applicable for car-based travel?
For car-based travel, I think you do have to look at the size. Probably the size is probably more important. The size, what I mean is the geographical size. Car accessibility extends way about to 60 minutes as a maximum desirable travel time. 30 minutes would be a median desirable travel time. So if your city is smaller than a 30-minute, if the edge of your city is smaller than 30 minutes, really I wouldn't recommend doing anything in the car space. But you'd probably look at deal with those small percentage but important percentage of people who don't have access to cars, and look at walking, cycling, and public transport accessibility instead.
Great, thank you for addressing those questions, Ian, and thank you for your time dropping into my webinar studio to chat with us more on the topic, and it's been very interesting. Once again, thank you to our kind audience who has tuned in this afternoon to view the presentation, and we're sorry we did go a little bit over time. Hopefully you can join us for future ARB presentations, and we'll be running them as soon as next week, so keep an eye on our email correspondence, and there'll be more information there about what's coming up. Once again, Ian Espada's details are on the screen there. Please take them down if you wish to contact him for any further discussion. Thank you all for your time, and
Thank you very much.
hopefully you can join us next time. Bye-bye.